Welcome to lecture 12. Here we're going to discuss the idea of vectors, okay? Vectors. Before we discuss vectors, let's define something a little simpler, something called the scalar, okay? What is a scalar? A scalar quantity is something that has a magnitude only. Magnitude only. Okay? What does magnitude mean? Magnitude means it's just a number. Okay? Just a number. Right? Everybody says age, it's just a number. Yeah, till they get old. Then they say it's not quite such a great number. Just a number. So you're 23, you're 17, you're whatever. Just a number. So I'm going to put examples. I'm going to put age. I'm going to put temperature. Okay? Temperature, it's 32 degrees. It's 112 degrees in the desert. It's minus 50 degrees in Siberia. Sorry, Siberia. Just a number. Okay? Later, we'll see that something like pressure is also a scalar quantity. Just a number. In the United States, we use pounds per square inch. So we can say the pressure in a tire is 30 pounds per square inch, 22 pounds per square inch. Simply a number. That brings us to a vector. What is a vector? A vector is a quantity that has both a magnitude. Now remember, magnitude means how big it is or how small it is. It's the size of something or the quantity of something. So it has both a magnitude and a direction. Okay? So it's this idea of direction that is important when we discuss vectors. And here I'll give you some examples. But again, you don't talk about your age being 23 years of age due north, or the temperature being 64 degrees in a southwesterly direction. So age is a scalar quantity, temperature is a scalar quantity, pressure, they're just numbers. A vector is a quantity that has both a magnitude and a direction. So let's give some examples in words, and then I'll give you explicit numerical examples of what we're talking about. All right. Up to this point, I've been very cryptic, or I've been very cavalier, or very careless, trying not to be, in using the words velocity and speed. I try to use the word speed. I try to use the word speed and try to use the word speed, even though I should have been talking about the velocity. So let's see what the difference is. So suppose I say a car moves at 50 mph, 50 miles per hour. What I'm doing is I'm telling you it's speed. Speed is a scalar quantity. It's a number. It's just a number. It's just 50 miles per hour. However, if I say this, a car is moving at 50 miles per hour due south. Now I'm telling you the speed plus the direction. I'm telling you the speed, right? That's the magnitude. Plus the direction. That's south. So 50 miles per hour due south is called the velocity. So velocity is our first example of a vector quantity. Again, why is velocity a vector and speed is not? Why just the speed is not? Is because the speed is just a number, 50 miles per hour, 30 meters per second, 1 centimeter per century, all just numbers. When you take the magnitude of the speed and put a direction to it, we now talk about velocity. Velocity is a vector because now we have a direction associated with it. Okay? So I'm going to write over here, because it's a good test question, which quantities are vectors or which quantities are scalars. So I'm going to put examples of vectors. Okay, we just had velocity. Okay, velocity is a vector. Okay, it has a magnitude and direction. We also are going to have acceleration. Okay, acceleration is going to be a change in velocity, not speed, over a change in time. Notice it's a change in velocity, not just a change in speed. I'll get to that in 1 second. Okay? Since acceleration is a vector, force, which is mass times acceleration, force is also an example of a vector. And again, we'll come back to that. Okay? Let me talk about acceleration for 1 second. Okay? And review a problem that we discussed earlier. Recall, if I throw an object up, straight upward, at an initial speed, let's just say at 80 meters per second. There's my initial speed. Or my initial velocity. 80 meters per second, straight up is the velocity. We know, because we're so damn smart, that every second the speed is decreasing by 10 meters per second because of the acceleration due to gravity. So one question I would ask is, how long does it take to get to the top? Well, clearly in 8 seconds, the speed is 0, right? At the top, the speed is 0. A trick question would be, what is the acceleration at the top? And naively, one would want to say, oh, speed is 0, velocity is 0, therefore the acceleration is 0. But if we think about it, think what we're saying. You throw an object up, it reaches the top of its path, and all of a sudden, gravity stops acting on it. In other words, there's no acceleration due to gravity. Clearly, there's something wrong, because clearly the acceleration due to gravity is still acting on it. But how could it be acting on it if it has 0 speed? Well, let's look. Remember, acceleration is a change in velocity with a change in time. I'm going to write this. A equals delta V over delta T. But remember, V has 2 parts. It has the speed, the magnitude, and it has direction. Okay? So if the velocity changes, the speed can change, and we know this. We know that as we speed up in a car, if you close your eyes and someone's driving in a car, someone else is driving, don't close your eyes, and they speed up, you feel a force, you feel an acceleration. And if they slow down, you also feel an acceleration or a force. What happens if you move, if you have your car at a steady 50 miles per hour, and again, they're driving, someone else is driving, you have your eyes closed, and they make a turn. Do you know if the car turns? And the answer is yes, you do. Why? Because you feel a force. How can you feel a force? Because there's an acceleration. How can you accelerate if the speed stays the same? Well, again, it's the acceleration is a change in velocity. So even though the speed does not change, you change direction. If you change direction, you also have an acceleration. And that was the case with centripetal acceleration. Do you remember? You remember an object going around in a circle? Remember, at every point, the velocity, not the speed, is tangential. Remember? V. V. The velocity direction is changing. If the direction changes, even though the speed is a constant, 50 miles per hour, whatever, then you are accelerating, and hence you feel a force. So when you throw an object straight upward, at the top, at the very top, the speed is 0. Velocity 0. What happens? The direction changes at that instant. At that instant, the velocity is going upwards, and then whoop, it flips, goes downwards. Because the direction changes, there's still an acceleration. Okay? So be careful. At the top, 0 speed, but it doesn't stop accelerating. Very tricky. All right. Let me give you a little story, and then we'll see how we can use these in a problem. All right, we're going to make up a story, okay? Here's a river. Oh, river with a great current moving very, very rapidly, okay? On this side of the river is our sad princess, Ivana. Okay? Ivana is very sad. Why is she sad? Because her prince is on the other side of the river, and he's very sad. And he's got a little crown. There's a little prince. And the prince plays his nice little guitar, and he plays love songs. Okay? And let's say this is Igor. Igor and Ivana. And he's playing songs, playing songs. And downriver here is the king, mean guy. Right? He's got a spear, waiting for anybody who messes with his daughter, Ivana. Well, Igor's playing songs, playing songs, playing songs. Finally, Ivana says, enough with the songs. Let's get together. Now, Igor's a little afraid of the water, but eventually he's so in love with the beautiful Ivana, you can see she's really something to look at, that eventually throws his guitar away. His passion takes over, hormones take over, and little Igor jumps in the water to be with his loved Ivana. What happens? Well, it's clear what happens. Igor starts swimming straight to his beloved. The current is taking him this way. The net result is he ends up by the king, and sad story, he ends up with a spear up his butt. Okay? Because Igor did not understand the concept of vectors. He swam straight across, the current took this way, and the result was he went at some angle. So if Igor wanted to be with his lovely Ivana, he should have stayed in physics class a little longer. What should he have done? It's clear. Igor should have swam downstream this way, let the current take him, and then our little princess would be one happy young woman. Okay? So what we've shown here is the addition of what's called vectors. So I want to talk about the addition of vectors so we don't get spears up our you-know-what. Okay? Just a quick mention of one profession that uses vectors and hopefully saves our lives are air traffic controllers. Okay? If you have a Southwestern flight going this way and a United flight going this way, knowing their speeds is not enough. You must know the vectors, what direction in space they're going. So when you put it in a computer, you can say in 12 minutes and 17 seconds, boom, they would collide. So you know their speeds and you know their directions. You put that in the computer and you can see if they'll miss or collide. Okay, air traffic controllers. Addition of vectors. First thing we're going to do is collinear vectors. Okay. Collinear, now it just means they're on a line. And these problems are so easy that when you do it on an exam, you're going to think it's too easy, and then you'll put the wrong answer. You'll take the square root of your oldest child's age and divide by the license plate number and figure out some wacky way of getting the wrong answer. It's this easy. Just watch. Suppose I have an object, piece of candy, and somebody pulls on it with 20 newtons force. And somebody else pulls on it with a force of 10 newtons. Well, what's the total force on this piece of candy? Well, look, 20 newtons, 10 newtons, The total then, you just add them. You get a total of 30 newtons. So collinear, when they're in the same direction, what do? You simply add them. Now, take a guess. Piece of candy. 50 newtons. Okay? 40 newtons. So somebody's pulling with 50 Newton force this way. Somebody's pulling with a 40 Newton force this way. What is the total? Well, again, they're collinear. One is in that direction, one is in that direction. It's clear when they're collinear in opposite directions, you simply subtract them. So the total would be what? Would be 10 newtons to the right. Okay? 10 newtons to the right. Simple, simple, simple. Do not make this more difficult than it is. All right, now let's do the hard part. All right, not that hard, but we do have to go back a couple of years to high school and review something. I want you to watch. Just watch what I'm going to do. Okay? Suppose this is east, doesn't matter, and this is north. Okay? Suppose somebody pulls in the easterly direction with a force of 100 units. Doesn't matter what it is. We'll put newtons, okay? And now suppose somebody pulls this way with an equal amount, 100 newtons on an object. What happens to the object? Where does it go? Well, again, just use your common sense. Don't try to use an equation. Use common sense. If someone pulls straight upwards with a certain force and somebody pulls this way to the right with the same force, since they're equal forces, the object's going to go right in the middle. That's going to be the object's motion. And you should understand that this is 45 degrees. Exactly in the middle. Again, it's common sense. They're equal forces. The object will move exactly halfway between each of them. Okay? So, let's do this problem. Let's erase this. And I don't care about the numbers, but I'm just going to make this 500 newtons. Okay, so this is a really large force pulling in this direction, east. And this is only 100 newtons. What's going to happen? Well, again, the object won't go right in the middle because this guy's pulling with a greater force. So what are we going to do? What's going to happen is it's going to go more towards the east than it is towards the north. So again, don't worry about the number. It's going to go something like this. And this angle is going to be less than 45 degrees, and this angle will be greater than 45 degrees. Common sense. I don't want numbers. I want you to look at this and look at common sense, okay? Once more, redraw. If I made the northerly force 500 newtons and the easterly force 100 newtons, again, it's clear that this force is going to dominate over that. And what's going to happen now is the net motion will be more towards the north than it is towards the east. This angle, again, will be less than 45. This angle greater than 45. Very, very simple. Common sense. Okay? So now I want to look, okay, hopefully you follow this bit of reasoning. What I want to do now is I want to look at forces that are not equal and see what happens. So let's just look at this. Suppose I have a force of 4 newtons, and now I have a force of 3 newtons. Okay? We agree that the object's going to go, I don't know, a little closer towards the 4 newtons. Okay? Well, what we do, it's called the parallelogram method. This vector is the result of this and this adding as vectors. We're going to call this vector the resultant vector. Resultant vector. Okay? And what we do is very simple. We take this vector, put the tail, great planning, put the tail of this to the head of that, put 3 newtons that way. And then take this vector, put it here. Okay? And we can make a parallelogram, or we can make a parallelogram here. The important thing to notice, oops, okay, 3 newtons. Okay? The important thing to notice is we have this right triangle. So I'm going to redraw this in a way that may look familiar, okay? So again, it doesn't matter. This is 3 newtons. I'll put just leave 3, and this is 4. I'll call this x. What is x? X is the resultant vector that we're trying to find. Okay? Hopefully, you have some memory of this from high school. Okay? Here, we have to use a theorem. Does anybody remember whose theorem this is? Okay? It's called Pythagoras. Pythagorean theorem. Okay, let's draw here. We have A, B, C. Do you remember this? Where the square A squared plus B squared is equal to C squared. Do you remember this? If we look at this triangle, we have x squared is equal to 3 squared plus 4 squared. So x squared is 9 plus 16 is 25. So x is the square root of 25. Remember, square roots, here it's an exact number. Otherwise, you can approximate. And here we get 5. All right, so the resultant vector would be 5. If I use newtons, it would be 5 newtons. Okay, so we'll be doing problems with the Pythagorean theorem. Let me show you one workout problem here. Okay, watch. I have an object of mass m. Okay, m equals 2 kilograms. Great. I have a force of 50 newtons. And I have a force of 30 newtons. Okay? I have a force of 74 newtons. I have a force of 110 newtons. I have a force of 90 newtons, and I have a force of, of 12 newtons. So here's a mass, 2 kilograms. I have one thing pulling 50 newtons this way, 30 newtons that way, 74 newtons this way, 110 newtons north, up, 12 newtons down, 90 newtons. And suppose now I ask, what is the acceleration of m? What is the acceleration of mass m? And your answer is, how the hell do I know? It's a good answer. So let's see if we can figure this out. First of all, if we go to Newton's second law, we have that the acceleration is F total divided by the mass. Okay? So what do we need to find out? Well, we know the mass, so we have to find F total. To do this, we just have to add vectors. Let's look collinear, okay? 50 and 30 is 80, but this way is 74. So if I have 80 in this direction and 74 in that direction, what is 80 minus 74? I believe we have 6 newtons to the right. Let's look vertically. 110 newtons going up. Here we have 90 plus 12 is what? That's 102 newtons that way. 110 going up minus 102, I believe, is just 8 going up. We need x. X is the resultant. X is F total. So we use the Pythagorean theorem. Okay, so we have x squared equals 8 squared plus 6 squared. Oh, this looks pretty good. 8 squared is what? 64 plus 36 is x squared. So x squared is 100. So x is equal to 10, or 10 newtons. But what was that? That was F total. Therefore, the acceleration is equal to F total divided by m was equal to, what do we say it was? 10 newtons divided by m, 2 kilograms. So A is, remember what a newton is? 10 kilogram meters per second squared divided by 2 kilograms. Kilograms go out, and the acceleration, oh, look, it just turns out to be 10 meters per second squared. It's just a coincidence. It's not g. It just turns out that it's 10 because I wanted to use easy numbers. So when vectors are collinear, you add them in the same direction, subtract them in opposite directions, and if they're perpendicular at right angles, you simply use the Pythagorean theorem. Okay, see you next time.